All right. Hey, welcome everyone. Um, yeah, you come to a strange place, and I'm glad to have you here. If this is your first time, this is our GC Agile community practice. We do crazy events like the one you're here, and we do a mentoring program, and we do a monthly lean coffee. Um, anyways, we're here today. We're going to do some really interesting big agile and data stuff with my favorite Scrum leader, Rick. Anyways, I'll be doing no work at all, but managing the chat. And if you have a question, I'll be doing a signal, managing these questions. So if you have questions, type them in chat or raise your hand, or I don't know, just speak up, and that'll be it. So, Rick, over to you.
Thanks, Todd. Hey, everybody. Good to see your icons and initials. Feel free to speak up at any time or post something in the chat if you have any questions or thoughts. And I look forward to talking with each of you after this to get to know you all a little better and find out about the challenges you're facing. So, yeah, this is, I'll go ahead and share a thing here so we have something to look at together. This is a session on data science projects in Agile. Right, Agile is a project management framework that you're all probably more or less familiar with. The idea is that we iterate rapidly, get feedback, and improve our ways of working and our products by observing, right, and learning as we go. This presents some unique challenges for data science projects, which are often neglected generally. A lot of people who do or plan data science work or data science initiatives don't really understand the nuts and bolts of it and how it works. So why am I sharing this with you? Well, I'm the Scrum leader at a little company called NoiseAware. They're an IoT startup that has sensors in short-term rentals and hotels all over the place. And we keep track of when things get noisy or when there's cigarette smoke or when there are other potentially damaging, disruptive things going on. And then we intervene and prevent that damage to the property and to the neighborhood. And this is a pretty big pain point for a lot of owners and property managers. They can actually get shut down, and then they're left with a property that they own and are paying for, but they can't make any money off of, which is generally a bad thing. So that's what we do currently, and there's obviously some opportunity for data science to have a role in that, right? How do you know when a thing is actually a thing? How do you know when that blip on the chart is a party and not a lightning strike? Those are the kinds of challenges that my teams solve every day. Before that, I was at a company that, again, had IoT sensors all over the place in all of North America's energy infrastructure. So all the major power plants in the US and Canada, we had little monitors pointing at them to figure out how much juice they were putting out. We had a camera pointed at Elon Musk's gigafactory, and we were counting the number of Teslas coming out of the factory on trucks. We had to train a machine to count truck, not a truck, and the number of cars on it. So huge number of data science projects there, analyzing satellite data to figure out oil production, looking at what's the future of power pricing look like in Texas in the next 24 hours, given the current weather conditions. Those sorts of problems we would use machine learning and straight up algorithms to solve. And we also dealt with a lot of different data sources. So we'd have some data over here in an Oracle database and some data over here in Postgres or MySQL. No common metadata store. We would have to figure out how to slice across these things. So some of these challenges may sound familiar or at least analogous to some of you. And I was telling Todd earlier, the key here is not that I know how to do all this stuff perfectly, it's that I've crashed a lot of rockets. So I've seen a lot of mistakes happen, and I've figured out some things to mitigate those mistakes. And that's what I'll be sharing with you today. are some of those ideas, some of those lessons learned that I hope will help you as you move ahead with your work in data science, either as a stakeholder or like me, a kind of project leader or a developer, whatever your function may be. So let's imagine this scenario. Let's say you've got a bunch of data, or many bunches of data, right? Could be scattered all over the place, and we need to do something with it. Maybe we need to clean it up. Maybe we need to analyze it to answer a specific question. How many geese migrate north across the Minnesota border at the end of the fall? I don't know, something like that. Or maybe, and this is perhaps the most dangerous situation, somebody, usually in a business or marketing role, figures that there must be value somewhere in these data. If we could just plug in the right machine and twiddle the knobs, we could have some amazing answer to some question that we don't really understand yet, right? But let's get a team together and figure it out, right? Which is both exciting and terrifying. Maybe some of you have been in that kind of a situation before. Usually you have certain players who are involved, certain stakeholders who are in this situation. You're going to have the SME. This is the person who actually knows what the numbers mean. You can have one or many of these. Sometimes the knowledge is spread across 2 or 3 or more people, but usually there's some brain out there, right? And you're looking at the stuff and saying, well, it says input date, but input to what and where and date and what time zone is this in and all that kind of stuff. Your SME is the person who can answer that for you. You're going to have an analyst or data scientist. This is somebody who either is really good at creating a model and or understands the larger systemic context in which these numbers originate. So they understand the market, or they understand the overall processing flow, or they understand something about the broader context, and they have an idea for how to do an analysis using these data that are going to produce value. You have an engineer. I could also write developer. This is somebody who knows how to code. They know what good, elegant code looks like. They know probably 1 or more languages pretty darn well. They do not necessarily understand how good models work. They do not necessarily understand the broader market context, nor do they really understand the data. But they know how to write good code. You have DevOps. This is a person who is in charge of getting good code deployed and functioning on servers. Different from the developer for reasons that many of you are probably keenly aware. And this is a really important distinction to draw out for reasons that we'll talk about a little later. And lastly, you have management. Sometimes management comes up with the idea for the project. Again, that's the most dangerous scenario. But once the project starts, they always want to know when it's going to be done. And that's their primary driver. So they want to see value delivered in a predictable timeline. So we make a project, right? And our analysts and scientists go off and they begin modeling things in their spare time. And actually I'll back up a slide here. So this person here goes off and starts writing stuff, doing stuff, right? Making a thing. And then they go and they realize, well, I better get this on a computer so that it'll actually run. I can't just do it in my local Excel file. So they hand it off to an engineer. And then the engineer has to, guess what? Rebuild the whole thing because it's not coded, right? M code doesn't run on a on a box in a Kubernetes container, right? So now the engineer has to rebuild it and operationalize it. That results in rework and delays and lots of conversation. Then DevOps has to deploy it. And guess what? None of it's production ready. There are keys inserted all over the place because you have multiple data sources. There are various differences between the data sets that the analyst or SME was using and the ones that are actually in production. So we've got to reconcile all those, a whole bunch more rework results. So by now, your management has been told 3 times that this thing is done. And yet it's not. And lastly, you have management. Now this dog's breakfast arrives at their door, and they look at it and then they go, hey, wait a minute, this isn't what we actually need. Or, hey, how's the team gonna support this? We need an internal tool to manage this model, right? All these other requirements all of a sudden at the very end emerge out of the woodwork and get dumped on things. So yet again, for a 4th time, this done project is not indeed done. Those are the kinds of missteps that we're gonna talk about today. And I've got 5 basic principles for you to think about that might help you to avoid some of these common mistakes. So before I get going into these in any detail, I just want to take a lift, see if Todd's picked up any questions from the chat, see if anybody here wants to raise anything in particular that they want me to focus on. Just take the pulse of this crew.
And no questions so far, but feel free to jump in at any time right now if you want. We're also caffeine.
Cool. Well, please feel free to pipe up because now we're getting into the content. So this is a great time to ask questions as we go. So tip number, and by the way, these are going to look awfully close to a lot of what you'll read about in the Agile Manifesto or the Scrum Guide. And that's not an accident. Those are 2 of my guiding documents. So you're going to see that influence here a lot. First is focus on customer value. Data scientists need to be on a team with someone from product whose job it is to focus on that value and who understands the customer, understands their needs, wants, desires, preferences, and can help shape the product towards that direction. You want only one project at a time. So I use the word focus here really intentionally. It's not just customer value as a priority, it's the focus on that. So you don't want a developer or an engineer or an SME or a data scientist to be trying to juggle 3 projects at once. It's not going to work. Or it'll just work super slowly and expensively, and you'll see massive delays. It's much more effective to force product to make a decision on which one of these is more valuable. If you could have one thing today, what's that one thing going to be? Okay, that's what we're going to do first. And when we get that done, we're going to go on to the next thing. What this prevents is 3 important things. And again, these are just things I've observed. These are not absolute truths. These are just my observations. But in the absence of good product representation and good focus, you're going to see competing demands creating waste. You're going to see that analyst or that data scientist distracted throughout, and it's going to put a tax and a burden on your ability to get this project done. You're going to see infrequent delivery. Are we going to meet the next milestone this week? Sure. You ask at the end of this week, well, actually something came up. 2 months later, you'll meet the milestone, right? So it just stretches everything way, way out. And lastly, because of that, your stakeholders are going to get restless. They're going to wonder, where's my cheeseburger, right? Where's the payoff? Where's the payback? So avoid those anti-patterns by doing the things on the left, by focusing on customer value. Second, this one is super easy, and also everybody skips it. You gotta set clear, valuable goals. So I always begin data science projects now with a clear definition of done. We will know this project is done when the model reflects the benchmark within 2% error rate. something like that. It's got to be a number. It has to be verifiable. And if nobody knows, pick a number. But don't just, if you discover the number isn't achievable later, fine, we learned something. But don't go in blind saying we'll know it when we see it, right? And any software developer would tell you that's a bad idea. Any web designer would tell you that's a bad idea. The same principle applies to data science. Don't go in without a number. Second, every iteration or sprint has to have a clear, valuable goal, even the early ones. An early goal for a data science project might look like we can access the following 4 sources of fundamentals data via a single API, and here's the spec for that API, right? So it's all plumbing. There's no model yet, but we've somehow developed something that's valuable. We now can access our data. That's hugely valuable to a company, right? So pick a goal, even in the early sprints. Those prerequisites have value. They should be listed as goals for the early sprints. And third, eliminate your biggest technical risks early. If you know that there's going to be a load problem somewhere, if you know that there's a data quality issue somewhere, if you know that there's an access issue somewhere, make the overcoming or addressing of that challenge the first priority. Because if you build around it and delay it, you haven't actually got anything. You haven't actually solved your real problem, right? If you do these things, it will help you, not guarantee, but help you to avoid a couple of common anti-patterns that, again, I have observed. I have like scars on my arms from all of these problems. Scope creep is a big one. If you don't have a clear definition of done, if you don't have clear KPIs, what's going to happen is you'll get to the end of the project, you'll bring it to the stakeholders, and they'll say, this doesn't feel right. I once had a meteorologist tell me that our data scientists needed to spend another 6 months polishing the model because the output didn't yet feel right. And this project was costing us, 150,000 a month. It was insane. And the returns were going to be minimal for that marginal improvement that might have taken place in the following 6 months. It's much easier to say no to those kinds of diminishing returns requests when you have that number up front and you're able to say, hey, we met the benchmark, it's good enough, live with it, right? Or draw up a proposal for why we should spend more. But this iteration is done. You now have what we agreed to. You can also wind up with an overworked model. I once had another data scientist spend, I kid you not, 1.5 years trying to get this model 1% closer to the reference output that she needed to achieve, when it turns out that that extra effort was totally unnecessary. It was just like a myopic obsession at that point. And nobody stopped her. Why? Because we had no benchmark. So she would say, it's not done yet. I'm not done yet. And when we went and actually looked, it was great. It was totally what we needed. We could have shipped 1 year ago. That actually happened. And third, you're going to wind up in this weird situation where, again, you present your results to the stakeholders and they're like, well, that's not good enough. Or tell me why that's good enough, right? So establishing that understanding up front is really crucial. Yeah, Todd.
All right, we got a question in the chat. Is that
Great.
right? Okay,
Go for it.
I'll do my best at reading it. But Dave, you'll have to tell me if I do you justice. So, in your experience, have you found it useful to start with the biggest problem or the easiest problem?
Oh, God.
We love low-hanging fruit,
Yeah, that's a great question. I would say neither. I would start with the most valuable problem. So I would line up all of these problems on a 4 blocker, and I would maybe map them out by size or severity. on one dimension, and then in the other dimension, I would map them out by ease of resolution. But then I would also go through and mark the ones that are fundamental blockers, meaning if we don't solve this problem here, nothing else is going to matter up the chain. And then those are the ones that automatically leap to the front of the pack, even if they're small, even if they're big, even if they're easy, even if they're hard, doesn't matter. But those are the ones that I always start with. When I have a choice. Sometimes you don't have a choice. You might also be dealing with a brand new team that's never worked together before. And in your first sprint, it might be a good idea to give them an easy win. And say, all right, folks, it's our first time ever working together. I just met you 5 minutes ago. Let's pick a goal that's super achievable that we can knock out for 2 weeks. And that'll give us a good solid start. We can get to know each other a little bit, and that will set the stage for the 6 months that we know is going to follow. But there's obviously judgment calls involved there. But when I have a choice, I always go for value.
Right. And Dave said, thanks, value plus critical path. Right.
That's it. That's it. So, okay, we've talked a little bit about our focus on customer value. We've talked a little bit about goals. Here's one that most people don't think of. Get yourself a cross-functional team. Include all the characters in the team. So you want that engineer, you want that DevOps person, you want that product person. If there's marketing involved, you want that marketing person. If there's an SME, you better have that SME. If there's a data scientist, you want them too. It's a big team, yes. And a lot of people say, well, isn't this wasteful? Wouldn't it make sense to just send that one person off with their data set to their cave in the Himalayas where they can go meditate for 3 years and then come back and bring us the model, right? Like that ever works. For the reasons we've already talked about, that is a horrible idea. It will not produce what you're hoping to produce in the time that you really need to produce it in. By then, the value will have slipped away. By the same token, build your environments early. If you know you're going to deploy this model eventually in the cloud, do that in your first iteration. Take 2 weeks and get your dev environment set up in the cloud. Get that DevOps person building, get that engineer coding, right? The model can go into the container later. Right now, all it might do is just say, yes, there are data in the table, hallelujah, and output like true or 1. Right? It can be the world's most stupid model in the first iteration. But the point is you've proven that you can access what you need and that you have your CI/CD set up. In doing so, you're going to reduce the technical risk of your project exponentially, and you're going to save yourself a tremendous amount of cost later in the project of having to productionize or containerize things, right? Do that first. Lastly, make sure that the team owns the work and empower them. If they need a tool, get them the tool. If they need to write this in Python instead of Go, let them write it in Python. If they want to directly query a metadata store that's controlled by another team, get them connected with that other team. Let them make the connection that they need, right? So a lot of times it really helps to have a Scrum leader in there to help with those kinds of blockers. That's a character role that I leave out of the presentation sometimes, but that's a function that needs to be filled. If you don't do those things, if you don't have a cross-functional team with all the characters in it, if you don't build your environments early, and if you don't empower the team to own the work, you will observe, likely, the following consequences. That includes people sitting around waiting for help. I once observed a data scientist sit around for 6 months waiting for database access. I am not kidding. Waiting for the data, What we need to get the data. Have we got the data yet? No. Well, let's keep trying to get the data, right? Get the person who owns the data onto the team tomorrow and get them started. Like, let's just do it, people. Reworking solutions we just finished. Why? Because they're not deployable, they're not scalable, they're not productionized. Lastly, additional projects to fix or build tools. If you deploy right away, if you build things to scale now, if you start managing them like you're going to manage them later, now, you will automatically build the tools that you need. You will realize, oh, wait, instead of hard coding these variables in now, we should really create a JSON file, that's going to sit in a bucket, right? And that's configurable. So all we need to do is change those variables in the bucket, and then we can, all right, that'll be great for testing, right? What if we test it this way? What if we test it that way? Well, let's make a tool for testing. And guess what? That tool is probably going to become a configuration tool as this thing goes into production, or it'll become a management tool. So build what you need. Enable the team to just build and do what they need. Okay, second to last one, folks. Design for quality. Again, question, Todd.
Hey, more questions.
Yeah.
So what is an effective team size range for a cross-functional team? The Agile community, we recommend 7 ±2 or 6 ±3. Some folks say no larger than 2 pieces. I think Jeff Bezos is one of those folks. There are challenges with managing large teams, but if a large team is needed, how do you scale? How do you scale this? Scrums are just one big team.
Yeah, I would treat it like any other project. So if your organization is good at doing Scrum at scale, then do it. Most of the data science projects that I've worked on, if you've got good people in the mix, you don't really need multiple teams usually. What you might need is better access to SMEs who understand the data. There's usually a lot of complexity there and a lot of work there. And those folks, here, I'll tell you how I tend to handle them. Having them come and expect to spend 100% of their time on the project is usually not a workable solution, because they're often the only ones in the organization with that knowledge. So they're in very high demand for other things, and you're never going to be able to monopolize them. But what you can usually do is get them to attend stand-up every single day, and then you book that stand-up for 45 minutes instead of 15. And that leaves you some padding. So questions will come up in the 15-minute stand-up, and then those SMEs can hang on, have the conversation with the developers, take it offline, set up a time later in the day, whatever they need to do to collaborate, and then the team can proceed. But as far as developer resources or actual data scientist or statistician or engineering resources, for most of these projects, you can get by with a 1 pizza team or a 2 pizza team with seven people is usually where I wind up. For a small company, maybe it's more like 3 or 4.
How's that?
Hopefully that helps.
All right.
Yeah, you might also find that you're trying to do too much in one go, and you need to break it down, refine it a little more and figure out where the real value chunk is, the real meat that you need to go for first, right? Could be another option. Okay. We've already talked a little bit about this. This one's maybe a little bit redundant, but I want to focus again on quality because I think it's really important. You want robustness. You want the system that you're building on to be scalable. So design the data lifecycle to function at scale. Don't build the model locally in an Excel spreadsheet as a first round if you can help it, or if you did, stop there. Right? Very next step, build out the pipeline that you know you're going to need. Don't skip that. If you're going to have to integrate with your platform, if there are tools that you're going to have to integrate with, don't delay that. Do it up front. Maybe you suppress those features. Maybe you comment out the code for now, but it's there. And when you're testing it, it works. And again, this is going to help you avoid productionizing, which is just rework, it's waste. It's going to help you avoid reconciling with an incompatible system that's out there that you didn't discover because you weren't looking. Again, seen that happen. And delays in releasing because things, suddenly the tests fail in production when they were working in staging or in development, right? So push it all the way through. Lastly, this is the last one, but perhaps one of the more profound ones. Your unit of work, especially for the data scientist early on, is knowledge and an experiment that tests a hypothesis and produces a result. So track that knowledge just like you would any other story or task in your Agile process, right? A common story for a data science project might read as follows. We expect that if we deploy a linear model against these data, it will be able to predict within 3% the hourly outcome of this variable over a 24-hour period. Okay, so what do? We build it and we deploy it, and then we test it and we observe the results. And those results get put in the Jira ticket, they get put in Confluence, maybe in your situation, they get put in TFS, they get put in whatever project management software you're using, right? And then archived in a knowledge base, be it Confluence, be it Google Docs, be it whatever, SharePoint, right? And so you have this it's almost like you're doing a scientific study, right? You're doing like exploratory science. You're building hypotheses, you're testing them, you're observing the results, and then you're forming another hypothesis. And that has value. That has real value. So you want to radiate those results out to the organization. You don't want that knowledge to stay bottled. Why? Because somebody else is going to trip over the same log a year or two from now, right? It also will help you with your stakeholders because your progress won't seem slow or vague. You'll be able to go to those stakeholders and say, here, initially we thought this and we tried it. And guess what? It didn't work. And here's why it didn't work. And from that, we learned to try this other thing and it works better. So you see, we're moving in the right direction. The stakeholders are going to be much happier with that than they will with, well, they're still working on the model. Model still needs help, right? It's also going to help you to avoid digressions because when you ask those questions and when you create those hypotheses, you're going to have an opportunity to put them all out on the board and then look and ask yourself, which of these is the most valuable one? Which of these do we really need to solve first? Let's address that question first. So it enables prioritization and it enables a discussion of value. Okay, and that, folks, is it. It's kind of simple. Again, most of it is fairly straightforward and follows from the Scrum Guide or from the Agile Manifesto, but hopefully, there are some quirks with data science, so hopefully this helped you all to start to think through some of those if you haven't already. And this is very much a working document, working set of thoughts. So if there are questions or counterexamples or other insights that you all want to share with each other and with me, please feel free to do so. And looking forward to a good discussion.
We have another question. So hey, lots of value I'm getting, speaking of value, but let's go in with this question. Any tips on overcoming the challenges associated with systematically low data literacy in an organizational context? this is still largely a reality in government.
Yeah. So people in the organization don't understand the data. That can happen in a number of different dimensions. Sometimes it's that they don't understand the technical complexities of how the data are currently structured or managed or stored or acquired or permitted. There can be weird regulatory issues, kind of extra content related issues. Sometimes it has to do with what is possible with data generally. People think that data are magic and can solve all of our problems. I think a big part of this is where your product owner can really help. Because if you have the right product person in there, yes, their job is to communicate value and need to the team, but the other part of their work is to broadcast what the team is doing and communicate what's happening to the stakeholders and to face outward. So a good product owner can really help, even if folks are not terribly literate in the complexities or intricacies of data. A good product owner can help get them aligned and can help them get on board and understand what they're going to be getting from the project, or help them engage with the team productively as needed. So that's my recommendation. My first thought in hearing that question is talk to your PO. And if you don't have one, get one.
And then the, we've got data literacy, but also digital literacy and knowledge about lean and agile on top of that.
Gosh, yeah. And that that's a big topic right there. It depends on who the audience is and what the situation is, obviously. But my go-to playbook is to draw the simple complexity certainty graph and say, look, there are some projects that are very certain, others that are very uncertain as to how we're going to solve a problem. And there are some challenges that are very simple and others that are very complex and have a lot of moving parts. Data science is almost always just to the upper outside of center on that 4-blocker. There you go. So they're not, we're not quite at chaos, but we're not at like changing a tire, right? And when you're in that meaty middle section there, you really want to allow the team to iterate. You want to allow them to try something, see if it works, observe the results, and then make a good decision moving forward, always towards value. So that's why we're not doing this on a Gantt chart, folks. You could go ahead and put in the effort of making that plan, but we will break it, and you will slow us down with all of those change requests. The other thing that I think can sometimes help is to emphasize that you're focused on value. So yes, it's going to be hard for me to promise you that we're going to have everything you want done by a certain date, but we can tell you that we are delivering the most valuable things first. So before any of the window dressing, you're going to get the meat. You're going to get, the burger patty before the bun. So hopefully that helps as well. And again, this is an old argument that everybody in Agile has to make at some point. So there are better narrators out there than I am, folks who are even better at convincing others to get on board with an Agile approach. And I just encourage you to seek those folks out. Check out the Scrum Alliance blog, scrum.org, and the Agile chats will light up. If you ask this question in there, you'll get 50 answers right off the bat. Folks beating down your door to help you convince those folks to get on board with a more Agile iterative approach.
Right. Another question. It's another from Dave. Have you seen departments effectively combine corporate IT, IM, and DM services with agile data projects to be incorporated within a corporate systems and not simply one of the projects?
Okay, I want to make sure I understand the questions. So it sounds like what you're asking is, have I observed multiple parts of an organization align around improving not just creating a model, but improving how the data are managed and collected and controlled and engineered? Is that kind of the meat of the question?
Todd, do you mind if I take 30 seconds to explain verbally?
Go for it.
Have 35 seconds.
Fantastic, so generous. So Dave Sampson here. I've been in government about 15 years. Background is really geomatics, so geographic information systems, where pretty much we would build systems from the ground up, and we were pretty independent from the program perspective. And then I was exposed to corporate data management at other departments, and now I kind of I'm a floater. I go and work on various data projects, and one trend that I tend to see, if you can get traction on an agile project in general, let alone data, hey, all the more power to you. But what I see is to the point of building, and I wouldn't even just limit it at data literacy. It's just data capacity, really.
Mm-hmm.
And now that we have more tools and more leniency with letting people, especially subject matter experts outside the IT realm, of getting involved, what I see is a proliferation of data projects that then never make it back to the corporate level to either be a sustaining system and to be able to extract maximum value out of it, right? So to your point of what can we deliver value to, and if we take a pure definition of a project as a business function that has a beginning, middle, and end that delivers value, I'm starting to find that a lot of projects deliver value during the project, but then there isn't that enduring value after the project is completed because it doesn't get incorporated with the systems. So then when the next agile data project comes, they have to build the whole system from scratch. They're not building on the previous agile system. So that's where I was getting to. Does that help to clarify my question?
Yeah. So I think there are actually two issues there. I have from my experience, I've seen kind of two related situations. Let me put it that way. One is an analyst or team of analysts create a model, and they do it locally, and they talk to marketing, and they get it sold to customers, and now their virtual machine is effectively a production server. And their little model on that VM is responsible for crunching numbers every day and belching those into a report that gets emailed to customers via Zapier or something, some wanky janky tool that they grabbed off the internet. And that situation is really fragile. So now you've got this thing that, yes, it's delivering value, but it sure doesn't scale. And there's no other project that can leverage it, right? How's that other project going to get access to the outputs of that model? How is that a sustainable architecture that another team can replicate? But the value's already delivered, so the business doesn't see a need to invest in scaling it or in making it robust. So that's one situation. The other situation that I've seen that resonates with what you're saying is you have a team and they're asked to solve a problem, and so they create a table for their outputs, and they go in and they do the calculations, and they set up, let's say they do it the right way, and they set up a Lambda or whatever, and there's a function that runs every so often that crunches the numbers, drops them in the table, and bam, we have our outputs. But they don't think through the whole context of the situation. They don't necessarily expect that somebody else is going to want those outputs. So they never put them on a queue to go somewhere else. Maybe for now that queue is a dead end, but in the future, right? That could create a backbone. That could be really, really valuable, right? For the project to scale and or continue or integrate with other parts of the business via a streaming architecture as opposed to a database centered architecture. So I think some of this, to answer your question a little more directly, some of this I think is a function of good architectural design and good design thinking. Folks on these teams are not necessarily empowered or chartered to think that broadly, but I think it's useful when they do. And the second thing I think is that the organization really needs to have some additional discipline and focus around what initiatives are in place. If you have rogue folks going out and just doing stuff, saying, "Oh, okay, now we've got data, we're going to go do stuff with it." No, we need to have a session where we sit down and say, what stuff are we going to do? What is really most valuable? What's going to help our constituents most? What's going to best support the priorities of this administration? What's going to best support our strategic vision? And then we're going to focus on those 4 or 5 things. And all those other good ideas, they are wonderful ideas. We are not going to touch them. We're not going to do it. We're going to take those people that want to go build that other project, and we're going to put them on this other project that really matters more. So that's my second thought. Does that help at all? That's a big, big, tricky question.
Yeah, I get it. There's a lot to unpack. I guess just to respond to your data API, I think that our data API in government is called email, and it's often triggered with a request. And I think because some corporate entities are not prepared to offer data management services at that level, it's left to the SMEs to exchange data, and we exchange data at the SME level through email, which is a huge risk, right? And then the other thing that you were talking about, those core decisions. I mean, now I would call it enterprise architecture, but in the past, just the importance of data stewardship and data governance, of which I think some groups, geomatics and science, like some of the subject matter groups really, really get it. And I think some of the new groups that are coming online in the data sharing world, and I'm thinking finance, I'm thinking HR, I'm thinking performance measurement, which are big things in government, right? But they may not have kind of that same level of thinking of data governance. And to some people, some data scientists, data governance is boring, but it is the one fundamental thing that actually enables us to be able to do our work, right? It is the thing that enables an SME to share data, to have permission to do that. So just a couple of responses to your remarks. Thanks.
Yeah, no, those are great, David. Those are great thoughts. And I think it's no mistake that the geography folks would have a real understanding of the necessity for good data governance, because if that city shows up in the middle of the Atlantic, it's just wrong with a capital R. Like that, everyone's going to question everything else about that map, right? But we as humans are more tolerant of slippage or errors in some of these other data types and use contexts. So yeah, hats off to the GIS and geography folks. I agree. And we could, now that I think about it, a lot of the projects that I've been involved in that involve geographic data, those were the most reliable data sources we had. They were really tight. Like we never had to question lat long quality. It was always right there. So yeah, right before I left my previous employer, I was helping to set up systems for data governance, and we were identifying the people that would need to, and the processes that they would follow to validate data and to look for outliers. And believe it or not, we were even starting to train machines to look for those weird cases and stuff. So yeah, I guess my two-word answer to your whole question would be organizational alignment. Yeah.
Oh, it's tricky.
Yep.
All right, got another question in the chat. So could you address the value / importance of open data in government in the context of your experience, theoretical findings?
I don't have a lot of experience in the public sector. I would say that when data were hoarded in some of the contexts that I've worked in, or when SMEs were not forthcoming with their knowledge or willing to share, it just hurt everybody. I mean, and one of the best arguments that I found to work through that was just to do what I call napkin math around the problem and figure out what the value is that we're losing because of this regulation or inhibition or, you know, this conservative legal opinion that's preventing us from working with one another or whatever. So I'll give you an example here real quick. You know, we had a situation with some customs data that were being hoarded by somebody in the organization. And we figured that if we were able to ingest and polish and leverage those data, we could add, you know, $10,000 sticker price to the subscription that we were offering to customers per customer. They would pay that much more for those data to be cross-referenced in commodity space. And then you just multiply that by the number of customers, slap that on the table and say, okay, just want to be clear here, your decision costs this organization 500 grand a month. That's a conservative estimate from our marketing folks. I'm not making that up. I'm not doing the thorough math on it, but you know, common sense indicates that the number is somewhere on that scale. In the context of public service, that might correlate to ER admissions. That might correlate to unjust outcomes in prosecution cases. That might correlate to, you know, megawatts of power that go to waste, whatever the problem is you're solving, right? So do the napkin math. Another thing I would recommend is don't stop at no. A lot of legal folks, a lot of the compliance folks, a lot of the data governance folks are really accommodating after they're allowed to say no, after you have the second conversation with them and have a lunch and get them to understand that you're not out to take over their castle. You just want to collaborate with their data. All of a sudden, they're an open book and they're actually helping to connect you with people. That happened to me a lot in the health insurance space with a big company here in the US, where we'd get no, we'd go, okay, can I just have a conversation with you about it? And then they'd begrudgingly say yes. And then we get through, right? And then it would work out. So again, a good product owner with some charisma can really help. Yeah.
And yeah, we're seeing in chat, it's data hoarding is definitely a great analogy for the problems we're facing. Yeah. Any other 5 minutes left? So any other questions? Feel free to go off mute, ask them, or anything you'd like to say. 5 minutes.
Yeah, go for it.
I'm going to jump in and say thank you, first of all. Really appreciate your perspectives. And, you know, I think it's very important that we have these conversations and that we realize that there are some real, you know, roadblocks and identify them. Like, for example, the way that I'm really, you know, appreciate you put it in terms of data hoarding. It's a very poignant way of doing it. It's probably very inappropriate to go and say to someone in government, you're hoarding data, give it to me, I need it for this project. I was in this position. I won't mention specifically where, but it struck me after a long time trying to build an experimental AI model, trying to find the data, which theoretically I believed could help us solve a particular issue that we were having, but came across a lot of barriers. Some of the barriers we talked about and we addressed is data literacy. You're already talking about data governance and data ownership. These are all kind of parts of the digital standards, what we call them in government, and it's something that it's a huge, very wide organizational, systematic mindset change that comes along with overwhelming amount of information, if you will, and learning that's required. And it's not necessarily that it's hard. It's just because for a lot of subject matter experts, this isn't specifically on their mind, because the data projects that I have come across in government quite often, I'm sure I can't speak for the entire government, okay, so it's a very narrow experience here. Quite often when they're trying to do something experimental, innovative, they kind of hit against the way that we've been holding on to data and managing data in the past. And I would sometimes wonder if we should start with kind of freeing the data before we could really harness it before, because right now it's it's already harnessed and chained in a specific way, and trying to kind of harness it again without removing these previous harnesses, it's kind of counterintuitive in some ways. So that's where a lot of frustration is. Now, as I was mentioning, there are sometimes very good reasons why it is like that. And they're very hard, serious legislative limitations. For example, we have great ideas how we can leverage data in one department, but we can't ask CRA to share their data, which I know they have. That would be very helpful to help us figure out effectiveness of certain program, as an example. This is a very public, well known. So do you have any kind of hints besides the ones that you have said? What do you think is the hope, the light of hope here for us in government to overcome these? I know it's kind of large, but maybe you can provide a fresh perspective on this, where a lot of us are scratching our heads on this. So thank you.
Yeah, a couple of thoughts that might help. One is I would make an effort there to separate the human and social blockers from the technical ones. We often, I forget the name of the law, that we recreate our social constructs in our technical and architectural designs. So the databases will be structured around the human department that builds it, as opposed to the type of data, right? So when you talk about freeing the data, I see it as that's a cry to move towards a less socially defined structure for the data and a more technically smooth structure. But that, of course, is a really problematic thing to do for a lot of people and a lot of reasons, right? I would encourage folks who are caught in that dilemma to think creatively. There might be proxies that you can use. If some of your data, for whatever reason, it was given in confidence, it has to be anonymized, whatever, right? Maybe there's a proxy for that measure that you can get elsewhere that will enable you to at least validate your result. And then you can go back and say to the folks who own the data, look, I validated that this works using this proxy. I'm within 5%. If you can give me the real data, we can really solve this problem. And again, here is the value that we offer. This is a perennial problem. What we're seeing in the US, I'm noticing, is that a lot of private companies are filling the gap, right? So if government isn't willing to share the data or to expose it in a way that's consumable, private companies are putting out IoT sensors in place to just gather it themselves and signing private easements on private property to just go collect it themselves and get it 6 weeks ahead of the government data that come out after the fact. So there might be a private sector opportunity there. Maybe you want to go start your own company. So yeah, I don't know if those thoughts are helpful or not, but
Very
yeah,
much so.
that's
Thank you. I think it's a longer conversation. We're out of time. I don't want to. Perhaps, if it's possible, what's the best way to follow up with you and maybe have a wider conversation? Is there a way to connect?
yeah. Let me do this. I can send Todd the PowerPoint, and he's gonna. I guess he can distribute it, but I'll also, while we're on the recording here, did I put my email on here? Oh, let me fix that real quick. All right, so I'll go ahead and present this again here at the very end of the video. It'll be on. I love that I work for a company so small that my email is just rick@noiseaware.io. It's like 45 people in the whole company. It's very refreshing. And coming to there out of a Fortune 100 has been a very eye-opening experience. It's like all the same conversations happen, all the same struggles happen, all the same dysfunction happens. It's just on a tiny little scale. So you can just have these little conversations and work it out and move on. It's been very, very interesting.
Well, that's awesome. So I will be posting this on our YouTube channel. We have 8 subscribers. Maybe you will be the 9th or Horizon. So we'll post this there. Please rate, comment, subscribe, and we'll send the deck and all the things, as well as contact information. Thank you all. Thank you, Rick, for this amazing presentation. Nice and captivating. That was great. And thank you all for coming. This was a lot of fun. A lot of great questions.
My pleasure, Todd. Thanks, everybody. Good to meet you all. We'll talk soon.
Thanks again.